Vancouver Sun recently received a letter saying that biking was worse for the environment than driving.
Who are you?
The basis of this claim was that the extra shower bikers usually take burns the energy equivalent to 1 liter of gasoline, which is more than a car would use on an average commute.
How'd you get in here?
Is this claim true? Today, we are going to test this with the applications of physics.
Get out of my house!
Looks like we're locked out, but it's okay. I stole his keys. Now, right now we have to calculate how much energy is actually used by the shower. So we have to make a couple assumptions here. Let's assume that water enters buildings in Vancouver at around 10 degrees Celsius, and that a sufficiently hot shower is around 40 degrees Celsius. Therefore, temperature increase is 30 degrees. Now, how much water is actually being used in the shower? Well, you can easily calculate that yourself by timing how long it takes a 1 liter container to be filled up by your shower. Convert that to liters per minute, and then multiply that by how long your shower actually takes. For this example, we're going to use 30 liters of water being used. 6 liters per minute for 5 minutes. Now, the following calculations are simple enough that a high school physics student could do them. The energy required to heat up the shower will be the specific heat of water times the mass of the water times the change in temperature. Now, the mass of the water we know will be the same as the volume of the water because of its density, which is 1 gram per centimeter cubed. Now, if we calculate all these things together, we will get 3.8 megajoules of energy. If we assume that the house's water heater is 85% efficient, that means there's going to be even more energy that's being lost somehow. Therefore, if we take this into consideration, the total energy that a shower requires is going to be 4.5 megajoules. As for the energy used by a car, it uses about 36 megajoules of energy per 1 liter of gasoline. If we compare these to the results of our shower, we know that these results are off by a long shot. But under what circumstances will these claims actually be true? Let's go inside to find out. Many of the assumptions that we've used today won't apply to everybody, so these variables will definitely change our results.
Thought I told you to get out. What are you still doing in here?
Let's say an amateur biker had an embarrassing bike ride today and needs some time to reflect on his incompetence. Also, let's give him some time to carefully shampoo and condition his hair.
First you break into my house, then you insult me? That's it, I'm calling the cops. Well then, go on.
Let's give him a 25-minute shower at 45 degrees Celsius. Let's also assume that the shower output is 8 liters a minute, giving us a total of 200 liters of water being used. If it's particularly cold outside, let's also assume that the water entering the building is 6 degrees Celsius, giving us a total temperature increase of 39 degrees. If we repeat the calculations with the 85% efficient heater, then that gives us a total of 38 megajoules being used, which is more than 1 liter of gasoline would have used. We can clearly see that biking isn't as harmful for the environment as driving, but if you take a really long shower, of course it'll take up a significant amount of energy. So, either bike with a short shower, or drive. But then again, you can also have another alternative. Don't shower at all. To 1 liter of gasoline, which is more than the...
What is the...
Alright. Alright, go ahead. Go ahead.
You can always...
Hello, look at your shower. Now look at back at mine. Now look at your shower. Yes! You guys are nothing without me.
Okay.
Bang! Bang! Oh no!
So,
Yeah, take off your clothes right now, and then just throw it.
that sounds so wrong.
I know. Now, how much water is a shower actually going to use? Well, you can... Where's the cup?
Listen to me.